Well, hello. Welcome to Computer Organization and Architecture, Math 230. Technically not a math course, but here at Southwestern College we do teach the computer science program through the math department. So this course, let me give you a brief overview as to what this course is about. The 20-second overview is this right here. So historically, this class was taught as an assembly language class, and when I first started teaching this class, it was an assembly language, and it would be 17 and a half weeks or so of pure assembly language. And then some years back, after looking at how and when assembly language gets used in the real world, and looking at other courses such as Berkeley, San Diego State University, UCSD, you could see that there was a shift in how this class is being taught. So we've moved from assembly language purely to a mixture of things that give you an overall broader view of how computers work together, or at least the components of a computer work together. And so by having a better understanding of that, it will enable you to take advantage of the hardware in many ways, and also to understand a little bit more about what your code is doing or not doing. So we start off learning how to program in the C programming language. And from C, we look at C and we learn certainly some of the details about C. We learn about linked lists typically, and certainly about pointers and integers and floats and so forth. But the beautiful thing about C is that it has low level capability with its pointers. And so a data type that's a pointer, just like an integer can hold integers, floats and doubles can hold floating point numbers. The pointer data type holds something we call pointers, but really they're ultimately addresses. A pointer contains an address. It holds an address to another variable. So by using C and then learning about pointers and how it works with memory, it allows us then to go further down from C into assembly language, because assembly language works directly with memory in many of its operations. So you'll see adds, you'll see load words, store words, but especially load words, store words, load bytes, store bytes. Those lower level assembly language instructions actually work directly with memory, similar to what we have seen, what we will see in with the C language. So we'll build off of what we've learned there. And so that's one of the beautiful things. So that's one of the beautiful things about learning C, taking it into assembly, because C will prepare us to better understand and give us something to build off of as we move forward into assembly. We use C because you've learned Java and very similar languages in many ways. And so once we've learned C, move down to assembly, and then we will then look at that assembly language, and look at how that language can be converted to a numeric representation. So every instruction essentially has a numeric representation, and in that numeric representation, it encodes everything that particular instruction is intended to do. Which registers are being used? Is it a load? Is it a store? That information we're going to find is actually encoded in the assembly language instruction, and it is encoded numerically. Once we've gone down from C to assembly and then to the numeric representation of instruction, then we ultimately want to learn how you take an instruction that's encoded numerically, convert it to ones and zeros, and we're going to see how those ones and zeros are then used to interface with the hardware. So those ones and zeros will be used to control and gates, or gates. Essentially, we're going to use Boolean logic to take an instruction of one and takes ones and zeros, and then use Boolean logic to control what happens with the rest of the computer, right? So we want to use those ones and zeros to help us make decisions as to what the instruction should do from a hardware level. So is that instruction getting something from a register? Is it getting two chunks of information from registers? Is it asking the memory to output information? Are we looking to write information? And so we will have then covered a significant part of the course, but that is the overview of the course. C, down to assembly, down to ones and zeros. Ones and zeros, how does it interface with the hardware? So it's a fun course in many ways, because it gives you, it empowers you to better understand what goes on. So looking forward to sharing this course with you. This course will be taught in Canvas. So the next segment that you will see will be a segment that if you've not experienced or had exposure to Canvas before, it will teach you more about that.